My name is Edwin van Wijk. I live in the Netherlands and I work for a company called InfoSupport as a principal architect. And that means I do a lot with software architecture, mainly microservices nowadays. And I've been wrestling with Docker, Kubernetes, and also Istio. And I want to show you today how you can use these tools to manage your microservices. This is the agenda for today. I'm going to do a very short introduction on microservices, Docker, and Kubernetes, and then dive into what a service mesh is and how you can implement that using Istio. First of all, microservices. I don't think that's a term that I have to explain to you guys. We see lots of organizations working with microservices, especially for greenfield situations, new systems that are being built. Most of the time, they choose a microservices architecture. And that gives us lots of advantages if you do it right, but it also adds some complexity because we see organizations with tens or even hundreds or thousands of services, and it's becoming very distributed, and that comes with a price. So we need to make sure that we know what's going on within our microservices landscape, and how do you do that? Well, that is one of the things that a service mesh can help you with. So that is why we could need something like that. First of all, Docker. I don't think that's also a term that I need to explain in depth, but it's basically this. We ship software in containers that are standardized so we can run them everywhere where we have a Docker runtime. And basically what we see is that organizations start with a container, so they have a nice pet project and they put it into a container, and then they think, well, this is pretty nice, maybe I should add some containers, run another application in a container, and another one, and before you know it, you have something like this, and then your developers and your operations people start looking like this. Like, wow, what's going on here? How do we keep track of what's going on? How do we monitor this? How do we, make sure that traffic goes in the right way through this microservices landscape? So what you can use, first of all, if you start building applications with Kubernetes, with Docker at scale, so if you have multiple clusters running, then you need something that's called orchestration. And that is what Kubernetes can help you with. Kubernetes is an open source tool. It was created by Google, and you can use that to orchestrate all your containers. And because Kubernetes is something that you run almost everywhere, you can run it on-premise, you can run it in the cloud. There are all kinds of SaaS services like AWS, you can run it on AWS. In Azure, you have Azure Kubernetes services, for instance. So there's lots of ways you can run your Docker containers with Kubernetes. And there's also a developer version, because what I'm going to show you today is running all on my laptop. If you install Docker for desktop, you can just put a check mark and it will install Kubernetes for you, and you can experiment with that on your local host. There are also other orchestrators out there, but what you see is that Kubernetes is becoming the de facto standard, and most vendors are using this for Docker orchestration. What I'm going to show you today, I want to do a very short introduction of which objects you can use when you work with Kubernetes. So first of all, we have nodes, and these are the machines that you run, eventually containers on. This is just servers. When you have a cluster somewhere, maybe you have it running in cloud, you need to make sure that if you build a service and run it in this cluster, that you can access this from outside the cluster. And that's what you use an ingress for. Then there's the notion of services, and these are basically the endpoints that you connect to from a client application. And through your ingress, you can reach a service, and then you can call something that's behind that, which we call the deployment. And the deployment in Kubernetes is where you deploy, hence the name, your software. Within this deployment, we have pods, and pods are the smallest unit within Kubernetes that you deploy, basically. So a pod, you can scale up to multiple pods, and this is basically the software that's running. And inside the pod, you have a replica set. This replica set will define how many instances of a certain pod you want, and then within that, you have your containers. Yes? I will put this in a picture, so maybe if you have a sample application, this is a picture of two nodes. So this is a cluster with two nodes, and I could have a deployment here. In this case, it's the source service, and it is running inside my cluster. It's a replica set of one, so I have one instance of a search service pod, and the container is in there. What I could do is create a search service, And this service I can tie to an ingress, so people can access this service from outside. So this could be a microservices that I can now call from a web application or whatever through the ingress, and then it calls into the container that's running in the pod. I could also have services that don't have any, deployments that don't have any services. So this is just a backend process. In this case, it's an indexing service that just kicks off once in a while and does some indexing stuff, but it doesn't have a service attached to it because I don't need to call that from outside my cluster or from another application. Another thing which is really cool about Kubernetes is that you can have multiple versions of these things running. And Kubernetes can also make sure that you can then automatically load balance between these different versions of the service. So what you see is that Kubernetes gives you some strength and some power to do stuff on infrastructure level, on a network level. So I could, for instance, say, okay, I want to load balance over the product service version 1 and version 2, and then the product service will take care of that. You don't have to do anything for that. So how do I work with Kubernetes? So say I have this cluster up and running in the cloud, and it's all good. Then I create configuration files, and you write these configuration files in YAML, and I will show you a sample in a minute. And this configuration file basically describes what you want. And then there's the Kubernetes command line interface, the CLI, kube control, and you can say kube control apply this file. And what then will happen is that the kube control will send this to the Kubernetes API, and stuff gets deployed on your cluster. So this is how that works. And the nice thing about this is that these are just YAML files. You can just push them to a repo. It's just infrastructure as code, and that's pretty cool. If we look at an example of such a file, I have one over here. And there's lots of stuff in there, and I will highlight some of these. But if you want to start working with Kubernetes, go to the Kubernetes documentation, because it's all described there, and there's a complete reference of what all these things mean. But there are a couple of things that are important. So in this case, I am creating a deployment. So I want to deploy something to Kubernetes. And then there's something that's very important, that is labels. You do a lot of stuff with labels in Kubernetes. So in this case, this is a web application, and I give it the labels system is pitstop, app is web app, and version is v1. And this is just labels that I have added to this one. It's open for you to do. I also put it in a namespace, and that's very important because you can separate things within Kubernetes in separate namespaces. That's really nice if you start to handle this. And then I basically specify what this deployment should look like. In this case, I want one replica, so one instance, and then I create a template of what this deployment should look like. And first of all, I also give it these labels, and then I specify the container I need to run. And what you see here, for instance, is this is just my container image that is in a container registry, and it will pull it down to your machine if it's not already there, and then it will start it up within the Kubernetes cluster. So in this way, I can describe a deployment. I also can describe how I want to make this available outside of the cluster. In this case, I am publishing at container port 7000, and if the pod might crash or there's something goes wrong, then Kubernetes will make sure that it gets restarted automatically. So also these always-on scenarios in which stuff that crashes is automatically rebooted, that's also something that Kubernetes can do for you. So once I have described this deployment, I can deploy this to my cluster. I also want to make this available outside of the cluster, so I define a service. And that's basically the same thing. I give it some labels, it has a name, it lives in a namespace, and then I specify how I want to access this application from outside. So in this case, I have a load balancer type service, and it exposes port 7000. And this will make sure that I can reach this from my local host, just in my browser on my machine, and then it goes into the cluster and then hit the web application that's in there, in the container. So this is how you define that. And like I said, there's lots of stuff that you can define within Kubernetes, and it's all described on their website. So I want to show you some stuff today. And people that were at my presentation last year at DotNext, they will probably recognize the application that I'm going to use because it's the same application. It's a small microservices application. And it's for a garage, so a vehicle servicing station. And the solution architecture of this application is not very complex. It's also not a very complex application, but it's all about what we can do with Kubernetes and Istio. So first of all, we have a web application because we need to have access to the functionality. And then we have three APIs, the customer management API, the vehicle management API, and the workshop management API. And this is for, well, obviously, managing customers. They have vehicles that they can bring in for servicing, and then the workshop people work with the workshop management API to schedule maintenance jobs and stuff like that. Within this application that I'm running on my machine, there's also some stuff going on with a message broker. It's RabbitMQ, and there's a SQL server on there. That's not important for today. We're basically focusing only on the web application and these three APIs and how they communicate with each other. So make a mental picture of this very elaborate solution architecture, and then we'll dive into what the application does. So I'm running that application on my machine with containers within a Kubernetes cluster, and this is how it's set up. So I have the web application service with the web application deployment behind that. So this is the deployment, this is the service, and then I have three deployments with the APIs, the customer management, vehicle management, and workshop management API, and they each have a separate service that I can use to hit this API. And these APIs are just RESTful APIs. Make sense? Any questions on that? Okay. So let's go into a demo. So I'm going to show what this application can do. It is not very complex, like I said. But as you can see now, I'm just hitting localhost 7000 on my machine. So this is because I opened up this port and I can hit the web application. And then there's the application. I will zoom in a little bit for you. I have customer management. I have vehicle management and workshop management. And I can just add a customer, for instance. And then it is registered in the system. It's not very complex. It's just, a CRUD application. It's not about that. This application is running now in Kubernetes, and I've also already added Istio. So in a moment, we're going to look at what Istio can add on top of Kubernetes when I run an application like this. And first of all, I'm going to show you what a service mesh is. Because this application, of course, doesn't have a lot of services. It's only 3 services and a web application. But if you have hundreds of thousands, then you need something like a service mesh, and that could help you very much. So what is a service mesh? A service mesh is basically an infrastructure layer that you add to Kubernetes, and it controls all the communication between all the services in your application. And this is very important because by doing that, it gives you a lot of capabilities, because all the traffic goes through this service mesh thing that you add to your Kubernetes cluster. And it can help you with things like security. So, for instance, mutual TLS, security between services, you can do that with a service mesh. You don't have to do anything in your application. You do that on an infrastructure level. But also traffic routing. And we're going to see some examples of that in a minute. But also monitoring. It's very important to know what's going on. And I will show you how Istio does that and give you a couple of examples. If you start looking at DevOps and things like, okay, I want to roll out my service, but I want to dark release it, or I want to do a canary release, or I want to do A/B testing. All these kinds of capabilities, you can do that using Istio because you can do a lot of stuff on the infrastructure level. So it's very, very powerful. So like I said, the service mesh handles all the communication between the services, and we call that basically the ambassador pattern. So the ambassador introduces 2 parties to each other, and then they can talk to each other. And if you look at the technical implementation of this, we always talk of a sidecar pattern. Just like you have a motorcycle with a sidecar, you put something next to your service, and this is going to handle all the communication. So if I look at the application that is running right now, here we have the web application talking to, in this case, 2 APIs. If you have a simple Kubernetes cluster running, they just communicate with each other. But when you add the service mesh, it will do something like this. Within each pod, an additional container is installed, and that's the cool thing about pods in Kubernetes. They can contain multiple containers. And if you have multiple containers within one pod, they can talk to each other because they know each other over the local network within the pod. And what this sidecar container does, it will make sure that every calls that I do from the web application, for instance, to an API, or all the calls that come into, for instance, the web API, they get routed through this sidecar. And this will make sure that all the communication gets handled. This is what we call the data plane. So all the data within my application is routed over the data plane. And then there's another important part, and that's the control plane. And within the control plane, there are, in this case, I've only drawn one pod, but there's a couple of components that you install on top of Kubernetes, which is, in this case, in my case, is Istio. And this control plane will communicate with all these sidecar containers. And that's two-way communication. So first of all, I can configure all these sidecars from my control plane and then push that to all these sidecars. But all the traffic that goes through these sidecars is sent to the control plane for monitoring purposes. So that's all gathered on the control plane, and you can gain insight into that using all kinds of tools. Is this clear? Anyone has a question on this? And I will show you how this works in a minute, but for now, this is how the concept works. And there are several implementations of service meshes. So you have Istio, you have Linkerd, there's Console is also looking into these kinds of capabilities. But they all basically work like this with a control and a data plane. So what is Istio? So we just saw the concept of the service mesh. Well, Istio is an open source implementation of that. This also was created by Google. And they've used a lot of open source tools that are already out there, like Envoy, Mixer, Pilot, all these kinds of tools. They have combined them into a service mesh offering. And for Kubernetes, because you can run it on in different ways, but on Kubernetes, you add a couple of custom resource definitions. That's the cool thing about Kubernetes. You can expand that with new concepts. And this is what Istio uses to enable these kinds of things. And the cool thing is that it not only supports HTTP traffic, but all kinds of traffic, as you see here. So gRPC, WebSockets, TCP, you can do all those kinds of traffic using Istio. One important one that I like to point out is Envoy, because Envoy is a proxy product, and Envoy is used by most of the service mesh offerings to be the proxy, so to be installed as the sidecar. Also, for instance, if you look at Service Fabric Mesh, that's a new product that's coming out from Microsoft. It also has a SaaS offering for microservices application. They also are looking into using Envoy as their proxy. So that's a very, very important part. This is basically a picture that I grabbed from the Istio website, from the documentation. And here you also see, again, the data plane and the control plane. And within the control plane, there are all kinds of tools that you use to set policies, to configure security, do all kinds of stuff. And this gets pushed to the proxy, to Envoy, and it will start working. And it will send back all the telemetry to the control plane. So how does that work? Because I already had this configuration file, for instance, the customer management API. We just saw that file. And what you can do, there's a command line tool for Istio control, and then you can say kube inject, and then feed it this file, and then it will add the necessary definition into the file. And then you can use this file to apply it again to your cluster. And we can look at the file like right now. So for instance, if I look at the customer management API service, this is only the service in this case. This is what I normally type myself. And when I add Istio to it, it will expand it to this. And I won't go into what's in here because it's a lot. But you can see that Istio does a lot of configuration for me. And when I then apply this file to my Kubernetes cluster, this gets all deployed onto the cluster. So that's pretty elaborate. So that is one way to do that. But it is a little bit cumbersome because every time you change something in your definition, you have to put it again through Istio control kube inject and then apply these files. Well, there's also another way to do it, and that is there are in Kubernetes what they call mutating webhooks. And there are multiple webhooks, but in this case, it's a mutating webhook. And you can subscribe to this hook, and then when you deploy a container to Kubernetes or a pod to Kubernetes, it will automatically inject it at runtime. And you can configure then what needs to happen. So that's pretty cool. And then every time you make a change to your configuration file, you redeploy it, and then automatically the sidecar information is being added. So what kind of capabilities does Istio, does this service mesh add? Well, first of all, observability. Observability is one of the most important things if you start working with microservices, because you need to know what's going on. What is my throughput? How many requests per second am I doing? Is there an error somewhere? So this is very important. And like I said, there's a couple of open source tools that Istio has grabbed, and they have built a very elaborate set of dashboards. And this all runs on top of Prometheus, which is also an open source tool for ingesting all kinds of telemetry. And first of all, I want to show you Grafana. And I need to tell you that this application is running here, but in the background, I'm running a load test. So I'm just firing requests at this application, so things start happening. And if I now open on my local host the Grafana web, the Grafana dashboard, I can see all kinds of telemetry. And this is the mesh dashboard, as they call it. And I can see that all my services are in here. I have my workshop management API. I have my vehicle management API. I have my web application. And for instance, if I look at the customer management API and I click on it, I get all kinds of data of this service. So what is my request volume? How many operations per second am I doing? And I'm not running a full-fledged a performance test on that machine, so it's just firing requests once in a while, so it's not very busy right now. But you can see that you can see all kinds of stuff. What is the client request duration? What is the server request duration? And there's lots more. What are the incoming requests by source and response code? So you can see that, for instance, there's also a 201 in here. When I created a customer, then I can see that the web application got a 201 from this service. Incoming request duration, and you can see that everything is also split into certain percentiles. So you can get a really good insight into what's happening with this service. If you have errors and stuff like that, it will immediately show up in here. And because this is Grafana, it's an open source tool, you can also build your own dashboards using the telemetry and the metrics that they specify here, and you can just build your own dashboard for your own environment. So that's pretty cool. Another one is, in this case, is Jaeger. Jaeger is also an open source tool, and this will give you end-to-end tracing of requests. And in this example, it's not very elaborate because it's every call is, I call the web application, it calls an API and it gets a response. But if you have a chain of calls, then it's very interesting to look at that. So for instance, in this case, I pick the customer management API and I find these traces, and then it will look up in the database, it will have all this telemetry, and these are all calls to the customer management API. And I can see things like what was the duration, when was the call, and also which other components were involved. And if I click on a certain request, I can just see what happened within this request. How much time was spent in the web application? How much time was spent in the web API? And as you can imagine, that if you have a very deep nested call chain, that's very important to see where's the bottleneck in, for instance, the performance of a certain call. If a system is slow, then with Jaeger you could find out what is the slowest call in there and then start optimizing that. So that's pretty powerful stuff. Then there's another one, and this is demo-wise, this is always the best one, and that is Kiali. This is also an open source tool, and I could look, for instance, at the workloads that's in here. And what you can see, workloads are just services being called within my system. And as you can see here, that Kiali is also aware of Istio. So for instance, my audit log service, that is a service running in the application, doesn't have a sidecar. And it sees that. But the customer management API does have a sidecar. So it is aware of all the Istio stuff. Also, if you look at the services, you see that it knows that there are sidecars or not. Another thing that you can do is that you can get a graph of your application. And this is completely dynamically built from the traffic, from the metrics that come back from all the sidecars. So it has deduced from my application that this is the topology that I'm running. And what you can see here, you have the web application deployment, calling into, for instance, the workshop management API service, and that calls the V1 of the workshop management API service, deployment, sorry. So this is pretty cool. And you can also say, okay, I want to see in the lines in this diagram, I want to see how many, what percentage of requests is going to which service. So this is pretty cool. So you can see in one overview which is the busiest service or which service gets the most requests. And if you start looking at this diagram closely, it's pretty weird because I have a sidecar installed in my web application and the 3 APIs, but not in my log server, which is a Seek server running in this application. I don't have a sidecar installed in my SQL server that is running on my machine. I don't have a sidecar installed in my RabbitMQ. And still, Kiali can pick up that there's traffic. Because like I said, also all outgoing traffic from the sidecar on different levels, on HTTP, on TCP level, it will pick it up and it will make sure that telemetry is sent to the central system. So even these connections, and you can also see this is a TCP connection, it picks it up automatically without me having to do anything to my SQL Server install. And then the best thing for demos, you can even live show the traffic that's going through the system. So this, by the way, if you want to make sure that your boss is impressed, if you want to do this inside your organization, make a demo and show him this, and he will probably take out his wallet and give you some money, because this is pretty cool. And of course, it looks really nice, and it is also great for demos, but let me tell you, if you have this in a production environment and there's something wrong, it is immediately visible in this graph. And you can also set all kinds of alerts. So this is pretty valuable if you have a microservices application up and running. So yeah, that's pretty cool. That's all about observability. Any questions on that? Who wants this? Yeah, I thought so. Sorry, yeah. Yes, great question. The question was, how will this sidecar impact the performance and the productivity of the service? Well, it has an impact. So, of course, it needs to do some stuff and it needs to send telemetry, but it is not a large overhead. And of course, for this application running here, it is negligible. But I've read some papers from people that have used this in a very large production environment with thousands of requests per second, and they had about a couple of percentages of overhead, but it's not a lot. And of course, if you start doing additional stuff, because you can do all kinds of policy enforcement in the sidecar, the more you do, the more impact this has. But yeah. Any other questions? Yes. Sorry. No, yeah, great question. If you have more replicas, so if I have 2 instances of, for instance, the customer management API, each replica gets its own sidecar. Yes, yeah.
Okay, yeah. Okay. Just a minute, please. Just a minute.
Is there an ability to write queries?
On the telemetry?
Yeah.
I haven't tried, but I guess so. So like I said, in Grafana, you can get all the metrics, and you could create your own dashboards with that. Yeah, I don't know if there's, you can probably write queries, but I haven't tried that, no. But it's Prometheus, and in Prometheus will give you all the information, and then you can write your own tool on top of that and query the data. So I guess that's possible, but I don't know if anything is out there. Okay. That's it about observability. Another great thing that you can do, because all the traffic that goes through this application is under your control. You can set all kinds of policies and rules around traffic routing. And this is pretty cool because, for instance, in this case, I have a V2 of my customer management API I would like to introduce into the system. It has additional functionality, and I wrote it, so I will put it into production. But because I wrote it, I want to be careful. So what I want to do is dark release it. And that means that I would like to bring it to production and test whether or not it works correctly, but I don't want to bother any end users because they are paying for my service. And if my service breaks, they won't pay and I won't make any money. So that's pretty gnarly. So what I want to do is introduce this service into the production environment. Well, a cool thing that you can do with Istio is that you can say, okay, bring this one into production, so deploy it on the cluster, but just mirror the traffic, the real-time traffic from end users that gets sent to the customer management API service, mirror that onto V2, but don't do anything with the result or the response. So the end user will know nothing of that. So the service will get traffic, you can look at its logs, you can go through Grafana and look at all the metrics, but it doesn't do anything, my end users doesn't know about it. And yes, of course, if from my API I do something in a backend database and I screw that up, then yeah, I have a problem. But in this case, it's only functionality on the query side, and I only want to see if it works and doesn't crash, but I don't want to bother the end users. Well, this is something that you can do with Istio. So first of all, let me show you how that works. So I have the application running, and what I can do with Istio is that I can mirror the traffic. And this is something, like I told you, there are custom resource definitions. This is also in the namespace networking.istio.io. And in this case, it's a virtual service. And a virtual service is basically a service that you overlay on top of the Kubernetes service, and you give it some policies, and then it starts enforcing these policies. So in this case, I say, for my customer management API, I want to mirror all the traffic that goes into V1, and I want to mirror that onto V2. Yes? So this is how I define that. And this version 1 and version 2 is basically my two versions of the service. So how does this work? Well, first of all, I have to deploy this file that I just showed you. I have to apply this to my cluster. So I have to say kube control, apply, and then I give it the file customer management API mirror. And this will deploy it to my cluster. There we go. And if I go back to Kiali and wait a little while, then we will eventually see that the customer management API will get an additional version. Of course, I have to deploy the version itself. So I'm only deploying I've deployed the virtual service now, and now I can apply and say, okay, customer management API service V2 Istio. And it will roll out V2 of the deployment. So this is what I'm getting now. And if I go back to Kiali, you see there's something going on. It says, hey, there's some activity here. And you also see a different color here than the other service. So it has detected, if I select this one, it has detected that it has a virtual service. So Kiali is completely aware of what Istio can do and can also give you insights in what's going on. Now, and if we wait a little while, because it has to spin up the container and all that, there it is. So now we see two versions of my customer management deployment. And we see some traffic to SQL Server and to the log server, and this is because all my services automatically check whether or not the database is there, and it will create it if not. So there's some traffic going on, but if we wait a little while, it becomes silent, and this V2 is just sitting there in my application, and it doesn't do anything. Now I've added the service, the virtual service, to this customer management API service. But I have to tell you something, that if I look at the definition of this service, there's something strange going on. Because like I said, you do a lot with labels. And in this case, I have defined this service to send traffic to all the services that applied to this label. So they have to have system pit stop, app customer management API, and version v1. And this means that this service is not yet aware of the v2 deployment. And I did that on purpose because I don't want it to be in production immediately. So I've added the virtual service to make sure that it only gets mirrored traffic. And if I now say I will change this service to ignore the version label, then it will be aware of both the versions, and then it will be able to mirror the traffic. So I will apply this, kube control, apply customer management API service. Oh. And as you can see, this is all I didn't save the file, yes. I saw it was unchanged, so you can see if I don't change anything, it will do a check. What do you want to happen? Oh, that's already there, then I don't have to do anything. So it's idempotent. And now I have changed something, and it has reconfigured the service. If we go back to Kiali, then in a moment we will see traffic from the v2 deployment. There it is. But we don't see any line back to the service because I don't want to bother any end users. And the service is actually getting hit now with requests. It's doing stuff, and I can look at the logging and see that everything is fine. But I don't bother any end users with it. So it's completely dark released. I can test it as if it was a production service. So that's pretty cool. But now I think, okay, nothing is going wrong. I don't see any errors here. I will bring it into production. So I want my end users to see this version. But because I wrote the code, I'm not completely sure yet. So I want to do that in a controlled way. And that is what we called a canary release. So what I want to say is, okay, I will bring it into the end user population, but only 10% of the users will see it. Or, and then there's lots of capabilities that you can use. Only people on edge, or only people from this region, or only people with this header in the request. There's all kinds of possibilities. But in this case, I'm going to show you that I can just divide the traffic in a 10-90% way to make sure that not all users get the new version. So how does that work? Well, I write another definition. In this case, it's another virtual service. And in this case, I say that on HTTP level, I want to route traffic, and then destination v1 gets 90%, and destination v2 gets 10%. And if I now apply this file, I will overwrite the virtual service with the mirror in it. You see, it's now configured. And then a line will appear between the customer management API service, the virtual service, of course, and the v2 deployment. And then I'm actually sending traffic from the end users to the deployment, to v2. And if I go to the application now, because I can show you what this additional functionality is. If I go to customer management, and if I start refreshing, then in 10% of the time, so this could take a while, you will see an additional little medal in the screen, because the additional functionality of v2 is that it gives me an additional status of the customer. Is it a gold status customer or a silver customer? Well, it's not doing it right now. It can take a while. Let's see, I think that I've done something wrong. Maybe I didn't save the file. No, it is configured. It should kick in a moment. There it is. So it took some time to make that happen, but you also see the distribution between these two will eventually come, because it's not all concrete math, but it will eventually come to a 10-90% division. And if I keep trying this, there it is. And now it's v1, f5, f5, f5. It's only 10%. But you get the idea. So some of my customers will now eventually get the v2 implementation, and other ones will get the v1. So, and what I could do now, for instance, is if I say, well, I'm pretty sure that this service won't cause any problems in production. You know what? I will just remove the virtual service, And then the service will just load balance 50-50 over V1 and V2, which is the standard functionality of Kubernetes. So I can say kube control. Whoa, you need to be able to type to do this. Remove virtual. And I have to give it a name, so it's the Customer Management API. Oh, delete, sorry. I'm always struggling with these commands, so you're not the only one. And now it's deleted. And then we will see that the distribution will go back to 50-50. So it should be increasing here. You already see it going above 10%. And now I will see more V2 implementations. So this is pretty cool. I've now done a dark release of a service, checked whether or not it was broken, introduced it a little bit into the live population, and then fully deployed it. And I don't have to change anything in my application. It is just all on an infrastructure level, and that is where the power of Istio and a service mesh basically is. Any questions on this? No. Who wants this? Pretty cool. Yeah, nice. Okay. Let's go back to the presentation. Where am I? Did I stop that? No, here it is. So then the final topic that I want to talk to you about, chaos engineering. Who knows about chaos engineering? So the stuff that they do at Netflix, that Simian Army, Chaos Monkey, stuff like that. Okay? That is also something that you can do with Istio. So what I have done in this application is my web application also has a resiliency layer. So I've done some stuff with Poly. I don't know if you know Poly, but that's a framework which you can use to build retries and circuit breakers and stuff like that. So if from the web application I call an API and it doesn't respond or I get an error, I will just retry a couple of times. And after 5 times or something like that, I will say, okay, it's really offline. I will now throw an exception. And I want to test this resiliency. And that's pretty hard to do in this situation. Because if I want to test the resiliency here, I must make sure that my service breaks. So what we do then, most of the time, is we grab the code of the service and we start building in some random errors and then put that into production to test this resiliency. Well, with Istio, you don't have to do that anymore. Because what I can do is, for instance, I can now use chaos engineering. And I pick the management API service as my victim. And I just say, okay, in 25% of the requests that you get, you need to return an error 500. Regardless whether or not the call to the backend, to the service, the deployment, and the database went okay, and everything is fine, I just want you to dispose this great response and just give it a server error 500. Or, and then you get to all the capabilities of Istio, give it an immense file, or give it some other strange timeout, or whatever. But you can mimic errors on the infrastructure level to test the resiliency of your calling application. And that's pretty cool. So how does that work? It's getting a bit boring, but I have a YAML file. And that's, in this case, the Vehicle Management API faults. And this is how you do that. So you define a virtual service, just as we did with the dark releasing and the canary releasing. And I say, on an HTTP level, I want to insert a fault. And I want you to do that in 25% of the time and make it a server error, an HTTP status code 500. And if I now apply this file, it will create a virtual service for my vehicle management service. So I will go back to Kiali to show you how that works. We will refresh this. Here's vehicle management. You already see that it now has a virtual service. It became purple. And then after a while, we will see things going bad. There we go. And like I told you, in Kiali, you instantly see what's going on. Any questions on it? Who wants this? Yeah. I think a lot of people start downloading in a minute. So this is pretty cool. So all these kinds of things you can do with Istio, and this is only tip of the iceberg that I've showed you. There are lots of things that you used to do in your own application that you had to do very complex stuff for, and now you can just do it on an infrastructure level on top of Kubernetes, and it runs on my laptop. And I've done this, the exact same demo, also on an AKS cluster in Azure, just by switching the context of my Kubernetes tooling, and it works exactly the same. And that's the cool thing about containers. If you have it up and running on your local machine, it will probably also run in your cluster in the cloud. And then there's the big disclaimer and word of warning. As I showed you now, lots of stuff in Istio is still alpha or beta. So the product Istio on itself is 1.x, so it's a production version of Istio, but lots of the custom resource definitions that you define in there are not final, and it's really in flux. And I try to be up to date with this demo every time. There's a new version of Istio, I upgrade it, and until now it was pretty painless. You just follow the instructions on the website and it just worked. But you know, you have to take this into consideration. If you start using this within your organization, it is basically experimenting. So don't bet your mission critical system, throw everything away and put it into Istio. You really have to get acquainted with this and make sure that you know what's going on. And also just start with Docker, then do a little bit of Kubernetes, and then add Istio. If you start on the Istio side, you won't know what's going on because lots of the stuff that they're talking about, you don't have any idea what it is. So you have to be incremental about that. There are a couple of important links. So Kubernetes.io, of course, that's where all the Kubernetes stuff, you can download it there. There's all the documentation. Same goes for Istio.io. And I think that with Istio, they also have very elaborate documentation on the concepts. So for me, it was really enough to learn this kind of stuff. And I'm way far from being an expert, but this is something that you can do yourself with the documentation. And everything that I've showed you today, the application, all the Istio scripts and all that stuff, if you go to my GitHub repo and then /pitstop, it's all there and it's all described. You have to go to the wiki. So if you go to the GitHub repo, and then you go to it's described here, and then you go to the wiki, then it's completely described. You have the solution architecture in there and everything. And there's also how you can run it using Kubernetes. Okay, we have time for some questions. Yes?
Why did you select Istio to try to use the things, not something else?
Yeah, very good question. Why did I choose Istio to do this and not something else? For me, at the time that I wanted to use this, Istio was the one with the most features. Because Linkerd is a very well-known one, but they don't have all the features that Istio have right now. So it was just more feature complete than the rest. Yeah, but there's lots of, if you now look at all the companies that do something with service communications, like the vendors like MuleSoft and what's this other guys? APG and all these API people are also looking into service mesh. Kong is also called a service mesh. So you see lots of different ways of doing this. And yes, I would suggest to do some research because, like I said, it's very much in flux. I don't know which will be the one that comes out as on top. Other questions? Yeah.
For the first release, thanks.
No problem.
And the question, can we see any message brokers traffic in Kali?
Yes, you can see that.
RabbitMQ, for example, yes?
Yeah, but there's a but with that, because like I said, you see here the information going to RabbitMQ. So I don't see that now, but if I, for instance, add a new vehicle, then I have broker information going to RabbitMQ within my application, and then you will see RabbitMQ coming up here, but that's on a TCP level.
Thank you.
Yeah, but if you want information of your broker, then most of the time you're better off using the monitoring capabilities of your broker. So for RabbitMQ, there's a management console, and you can also see everything there. Yeah, but the network traffic is visible here. Yes? Other questions? Okay, well, we will go to the discussion zone, or did I miss one? No. Go to the discussion zone, and then we can get into more details. Yeah.
Thank you. Just simple question. Did you find any disadvantages of Istio during exploitation?
Yes, it is fairly complex. So you have to really get your head around what am I doing, because you're on the infrastructure level. I'm no infrastructure specialist. I'm a developer, so I had to learn a lot of stuff about what is an ingress and what is a load balance and stuff like that. So it is complex. Other than that, I haven't found any real drawbacks. Everything that I wanted to do, I was able to do, and yeah, without any caveats in there.
Thank you.
Yeah.